Hello, looking at the projects for Computer Science GCSE again. Last video we looked at trying to get a better understanding of the project and what is actually trying to get us to achieve and what it will look like and what are the different parts of it. So hopefully we now fully understand what it's actually asking us to do. Now what we're going to have a look at in this video is trying to break down the task into smaller, more manageable chunks. So decomposition. Yes, that is a potential exam question. Breaking down a problem into smaller parts is decomposition, and that's the process which we're trying to go through now so we can manage the challenge. If you told me just to write a program that does whatever your task is, then I would find that difficult. What I do instead is try and break it down into more manageable parts, and to do that I use a structure chart. Now I've done one for Connect 4 with my class before. It's not the only way to do it, it is a way to do it. And it's very important to understand that a program can be created in many different ways. Don't think just because 100 students are writing the same GCSE task that there will be multiple ones which are the same. In the same way that if I asked 100 people to write an essay about something, you wouldn't find duplicates. You may find some similarities, but you wouldn't find the same essay by multiple people. You don't find the same program by multiple people. Your approach to designing it, your approach to implementing it is different between the different people, even if you're following a very similar structure. So if what you're doing is different to the star of the class or somebody who you look up to, then don't worry. It doesn't mean that it's wrong, it just means you're taking a different approach, and that can equally work. So let's have a look at one which I've made previously, and it will show you what the outcome will look like. And then I'll go through one of the AQA tasks and try and break that down myself. So let's have a look at this one. So as you can see, this is Connect 4. So what we did was, the challenge was to create a game of Connect 4. Hopefully you know what that is. If not, pause and go and Google. So wrote a block at the top, ignore everything else, so we're just thinking about the top one. In fact, let's block off the other one. There we go. Connect 4. That's the only thing which we're concerned about. That is the program which we're trying to write. Just writing Connect 4 off the bat is remarkably tricky. So breaking it down into smaller parts. So Connect 4, what does Connect 4 comprise of? Well, it comprises of displaying the board, taking a turn, and checking if anybody's won. So with just those 3 steps, you've summed up what Connect 4 is. You've broken down the overall program into 3 distinct steps. You should be aiming between 2 and 5 different steps, hopefully. It's roughly. Okay, so display board. Are we able to do that? Can we take the board which we're storing in a variable and put it onto the screen? However you do that, that should be doable in that task. So if you're happy with the task that you can do that task, then you don't need to break it down any further. Take turn, however, is a lot of trickier. I don't know how you'd go about taking the turn just to sit down and say, well, it's obviously, and writing it. Same with check win. How do you check a win? There's a lot more to it than just saying, well, let's check the win. Display board, yeah, worst comes to the worst, you can just print a list. I've seen various different approaches and various different looking boards. You can go as fancy or as simple as you want, but that is manageable in itself. These are a lot more complicated, so we break them down again. So taking a turn comprises of alternating the player. So if it was the red player's turn, it becomes the yellow player's turn. Getting the move, so asking the player, what square do you want to put the counter in? That's it. And then add to the board. Now, can we write a program which alternates player, goes from red to yellow and from yellow to red? That should be manageable in itself. I'm not saying it's easy, I'm not saying it's going to be 2 seconds, but it's something you should be able to achieve. Getting the move, asking the user which square you want. In the simplest form, it's an input statement. In a fancier form, it's using validation, it's checking that it's a number, it's checking that it's between whatever column to whatever column. So you can do that in a function. It's a fairly simple, or can be made more complicated as you wish. And then add to board. Now add to board, you may say that that's simple enough. You just put something into the list, into the array. However, you could say, hang on, I need to break that down a bit more. I need to actually put it into the board, but I also need to apply the gravity. And that will cause the counter, you add it to the board in column 2, and apply gravity will say, actually, it should go down to this position here rather than the top position or whatever. So apply gravity would look at a list, look at the column 2 and say the first empty space is in row 3 or in row 0 or whatever. It's not easy, it's not something which you'll be able to do in 2 seconds, but it's something which is achievable. So the idea is you're breaking the whole thing down into achievable chunks. Same with check win. Checking win on its own is quite tricky. Now if you say, okay, just check for the wins on the horizontal, that suddenly becomes a lot more achievable. Then another function which is checking for wins on the vertical is a lot more achievable. Checking for wins on the diagonal is a lot more achievable. Then when we're running the check win function, all we're doing is saying, okay, check horizontal, check vertical, check diagonal. Are any of those true? If they are, then the win is true. All take turn is doing is alternating the player, getting the move, and then adding the move to the board. You can do some validation, sort of if it's can't add it to the board, go back to get move. It's not everything, but it breaks it down so you can solve the individual challenges in their blocks. Once you've written something like this, then these essentially all become functions. So your main function, your main program, will call these 3 functions. Your take turn function will call these 3 functions. Your add board function will call the apply gravity function. Your check win function will call these 3 functions. So you're breaking it down, and that is directly translating to your program. Okay, if we go back to the actual AQA project which I was looking at, so this one is the ASCII Art project, and you should know what run length encoding is if you're doing GCSE computer science. So it's converting AA to 2 A's, D to 1D. There's 6 8s in that group, so it's saying 6 8s. Yes, it is using 2 digits for each one, so it's O2 A's. That means that you can do 10 spaces, 6 8s, and so on. Okay. We should know what we're doing from the previous task. Now on this one, it's displaying a menu and then it's doing the various tasks. So the very first block which we're doing is going to be ASCII Art. Helps if I'm not writing. There we go. So that's the name of our program. So start off by writing the name of your program in a nice big box at the center of the screen. And then you can draw a box around it. Okay, so that's our program. Now there we go, pencil would be a bit nicer. Bit more of a solid line. Okay, so breaking down ASCII Art, the program ASCII Art, what does it comprise of? Well, the first thing which it will comprise of is displaying the menu. Oh, what size did I do that? 34. So display menu. That's our first chunk on our program. That's the first thing that we're breaking it down into. On here, what it needs to do is display the menu, then do whichever one. Okay, so that is our first item, and we'll draw a box around that. I would highly recommend doing this with pen and paper. Doing it with whatever program, be it Word or Photoshop or whatever, just makes it a lot more complicated. Stick to pen and paper. You can then scan, you can take a photo of it, whatever, to get on the computer. This is why that completed one I did on the board, because it's a lot easier to do these like that. Okay, after you've done the menu, so ASCII Art is going to be displaying the menu, then what? Well, depending on what they've selected, it could well be enter RLE. And that is asking how many lines of RLE need to be entered, getting them all, and then decompressing the data and displaying the art. So the user could be entering something like that a few times, and then it needs to be printing that. Okay, so the first step makes sense if it's just enter RLE. So that is the menu item which we're breaking down into. Draw ourselves a box around that. On this one, it does need to connect to these ones. So that's what we should have so far. Now, enter display menu. Yeah, I'm good with that. I know how to display a menu and get an input from it. That should be fairly simple. Now, enter RLE, there's a lot going on in that. Having all of that in one program, in one function, is tricky. So I'd break that down. I'd break it down, so in here I just have the actual asking for the data, or you could have it broken down into two different stages. So you can have it getting the RLE from the user, and then convert or decompress RLE, because this form is compression. Okay, so that is a perfectly valid way of doing get RLE. one box, there's a second box. Now, oops. Again, use pen and paper. It's a lot easier. Okay, so enter RLE is the menu option, and then get RLE from user. We'll just keep asking the user for RLE until it's got the right amount, and then it will pass all of the stuff onto decompress RLE. So enter RLE function will essentially be input how many lines do you want, and then call get RLE from user with however many lines they've asked for. So that may say get RLE from user 5 lines, and then that will just have 5 input statements, a loop, so it's doing the one input statement 5 times, and it will be returning the complete RLE from the user back up to enter RLE. And then enter RLE will then pass that RLE into decompress RLE, and it will get back the decompressed data. It can then just print it to the screen, and you've done that section. Okay, the next one is display ASCII Art option. So we're doing exactly the same thing. So the function is display ASCII Art. That gets extended a bit. So what this function should do according to the task is asking the user for a text file, reading in the text file, and displaying it. So all that is still a bit of a mouthful. I would prefer to have another function which is get file contents, and all that does is take a file name, gets all the stuff, and returns it. So just all this function has to do is say input what's the name of the file, get file contents for this file, and then print out the result. So yeah, it only has one underneath it, but that's fine. Okay, so the next one is where things get slightly more interesting, because it's convert ASCII Art. Now let's have a quick look. What should that do? They will be entering the name of a file which contains the compressed data. It reads it, decompresses it, and then displays the image. So we've got convert ASCII Art, but that is a lot to do just in one function. This is the last one I'll do as an example, and then go in a bit more in depth next time. Okay, so then what is convert ASCII Art? Well, first thing it's doing is getting file contents. So we can do that again. There we go. So we're reusing the same function. Makes things a lot more efficient. And at this level, I'd explicitly copy it out again, maybe put a note or an asterisk or something to say that they're the same file. So after it's got the contents from the file, which is the RLE, what does it need to do? Well, it needs to decompress it, which we've already done. I say done, I mean we've written a box, got a box for it. there. Okay, there we go. So now convert ASCII Art is just calling these two functions which we've already created, and then so suddenly the project is getting a lot more manageable. Okay, you know what, I'll just finish it off just for completeness, because the next one is the last one, and that is convert RLE, and that is getting a text file reads the contents of it, compresses each line, stores the compressed value in a new text file, and calculates the difference between the number of characters for each of them, so it says how much you've saved. Okay, so it is going to need a bit more space. Move that over there. Again, we're just drawing our boxes, making it into a nice chart. Extending that out, that's our last one. Convert RLE, what's that doing? Well, the first thing it's doing is getting the file contents. So it's getting the contents from the file. We've done decompressing, we haven't done compressing yet. So we need another one for compress ASCII. There we go. And then, given we've got the result from get file contents and we've got the result from the compress ASCII, we should be able to do the maths in just the length of that one minus the length of that one. So that shouldn't be a huge issue, but then we'll need to save it. So the final block we need is save file. Yes, you can do it in convert RLE, but hey, let's just make it a bit more explicit, a bit more manageable. There we go. So that is a design for an entire program. Similar, but you've got your own program to create. You should be able to use the same process. Make sure you fully understand what it's asking you to do, then you can do a decent design of it. Best of luck, give this a go. Next video we'll use it and we'll get a bit more information from it.